This is the form of energy we are going to look at whatever we discuss in thermodynamics. So this is our form of energy. We will be measuring this in form of different parameters and quantities, but whatever we measure will be our energy units. The units we generally refer to here are joules, calories, watts. This generally represents the rate of heat transfer. This is the quantity of heat. So these are the basic units we will be referring to. This form of energy is transferred on temperature difference. If we do not have a temperature difference, we cannot have a heat transfer. However, physical contact is not necessary. What we really require or what is really necessary is the thermal contact. This is going to be a necessary condition. Heat is transferred by means of three different processes. We will be taking up each process separately in our discussion. Those three processes are conduction, then we have the convection, and thirdly we have radiation. These three processes are various modes of heat transfer in our process of discussion. We will not be considering any other form of heat transfer whatsoever. Next, we look at the effect of heat or effect of temperature on physical bodies. In that area, let us first discuss about thermal expansion. By thermal expansion, what we really mean is we have our body and we can expand or we can increase the dimensions of that body by simple heat transfer or by making a temperature difference. Let us say we have a body at some temperature, we increase its temperature and thereby its dimensions increase. This generally happens due to increase in the intramolecular distance. We will later discuss when we increase the temperature or increase the heat inside a body or increase the internal energy of the body, the intermolecular distance or intramolecular distance rather, say we have molecules like this, the separation between them increases. That is because each molecule here vibrates with certain amplitude along its transverse or longitudinal direction. As they vibrate and we increase the temperature, the energy associated with each molecule increases. This is something we will be deriving later on in our discussion of gaseous state. So when this intramolecular distance increases, we will be having the length or the dimension of the body increasing. That is coming as an effect of increasing temperature. First we look at linear expansion. Let us say we have a rod. Let's say the length of this rod is L. We also say that this rod is at a temperature T. Now what we do, we increase this temperature to say T plus delta T. So now the rod is at a temperature of T plus delta T. Because of this change, we will be having an increase in the length of the rod to say, let this be L plus delta L. Note that this is occurring provided we are assuming that this rod is very, very thin and other dimensions in comparison to the length of this rod are negligible. The other dimensions being, say, the width and the height of the rod. They are negligible in comparison to its length. So we are not considering the expansion of those parts. That is why it is termed as linear expansion. So when we have this effect, we see experimentally that this delta L is proportional to the length. So greater this length, the greater will be its expansion. And we also have this change in length proportional to this delta T. Delta T is nothing but the temperature difference between the final temperature and the initial temperature of the rod. This delta L becomes proportional to these two quantities. This has been observed experimentally. Now, from this and by simple mathematical calculations based on different experiments, we find that delta L here becomes equal to L alpha delta T. This alpha here is the coefficient of linear expansion. This delta L is the change in length. Capital L here is, as you see, the original length, and delta T is the temperature difference. So if we heat a rod like this with a temperature difference of delta T, we will be having a change in length of this amount of this rod. Having said this, let us now look at volume expansion. Volume expansion, as the name implies, this will result in an overall increase in the volume of the body being heated. So let's say we have a cube. Let's say each side measures L. Now what we do, this cube which was at an initial temperature of T, we increase this temperature to say T plus delta T. This results in a change of volume from V to delta V. Because of this change in temperature, we have a change in volume. This change in volume, similar to what we had earlier, will depend on the initial volume, and it will also depend on the temperature difference. From this, we get delta V to be equal to V gamma delta T. This gamma here is known as the coefficient of volume expansion. Because we have two different parameters to measure expansions, it will be convenient for us if we had some relation between this gamma and that alpha. So let us find the relation between them.